Section 1.6 on using linear models to make estimates and predictions. This is part A on finding equations of linear models by hand. Okay, so in this first example, retail sales of skincare products were 4.7 billion in 2002, and they have increased by an average of 0.23 billion per year. So I want to write a function that describes this model. Now the first thing I notice is that I have this phrase increased by an average of 0.23 billion per year. And it's increasing that amount per year. This is how much it's changing each year. It's the rate of change or the slope. Okay, so now I know that the slope of this model should be 0.23 billion per year. Okay, now I know that if I write the equation of a line, the form would be y equals mx plus b, where m is the slope and b is the y-intercept, which is the ordered pair 0, b. And 0, b, since 0 is the independent value, if the independent value in year is year in this case, that would be the starting amount, the starting value. Okay, so it turns out that since I have an amount in 2002, if I defined my ordered pair to be since 2002, so we'll call it R. We'll let R be retail sales, and we'll call the other variable T, and we're going to let that be years since. I just use T for time, it's a common variable for time. Years since 2002. Okay, now independent is going to be years, and dependent is going to be the retail sales. So my order pairs would be in the order T, R, and in this case, year since 2002, if I choose that's my starting year, I've got 0 for the first year, 4.7. And that means that since I have a starting year at 2002, going on a long explanation here, long explanation, but if 0 is my starting in 2002, any ordered pair that's 0 followed by a number is my y-intercept, which gives me my b value. Okay, that would mean b would be 4.7 billion. Okay, long story short, that's going to allow us to write the equation. Just trying to explain how I know that I have the two pieces that I need in order to write a linear model. Okay, so this equation would be y equals, I know the slope is 2.3, so 2.3x plus the b value is 4.7. However, I'm not going to be using letters like x and y for my final answer in a model. In a model, I want to use the letters that relate to the problem. So I'm going to use r and t. R is the dependent value, that's the y value. So I'm going to replace this as r, and I'm going to make it a function, so not just r, but r of t equals n2.3. We're going to replace the independent variable x with t plus our 4.7. So I've taken it and changed it from an equation to a function. My goal was function that models the situation, has the letters that imply the situation. Okay. So again, I'll probably be a little more elegant, hopefully in example 2. I was trying to really try to explain how I pulled that information for the first time into developing the slope and the intercept. But I was given the information I needed to write that model. Part B, use the model to predict when the retail sale of skincare products was 3.5 billion. Okay, so 3.5 billion is a revenue value, so that is an R value. So I'm going to plug that in on this side of the equation for R of t, and I'm going to solve for t to discover when. Okay, so we'll start with 3.5 equals my 0.23t plus 4.7. Notice that the units everywhere are billions, 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 billions. The units match up, so I'm assuming all the units are the same. If one of them was millions, I'd have to convert it so they were all the same, whether it was billions or millions or whatever. Okay, so we're solving. So solving for t, I'm going to want to subtract 4.7 from both sides. And let me grab my calculator. I need to do 3.5 minus 4.7. So that gives me negative 1.2 equals 0.23t. And then I want to divide both sides by 0.23. Okay, so that gives me negative 5.217 equals t. Okay, so just a few things about that number so far. First of all, since it is negative 5.7, that negative is telling me that it is before the starting year, right? So my starting year was 2002. It's negative, so it's going to be before 2002. And I'm just going to actually take that value, just go ahead and add 2002 to it to figure out what year it would be. So 1996.7 means that it's more than halfway through the year 1996, but it still is in the year 1996. So I'll make a note of that over here. Negative 5.217 plus 2002 is equal to 1996.783. Okay. My conclusion, I'm going to round it because I don't need to say 1996.7 as a year. We'll just say in the year 1996. What was this about? Skincare sales? Skincare sales were our 3.5 billion. All right. Let's look at example 2. The percentage of Major League Baseball players who are African American has declined approximately linearly from 17% in 1997 to 8.4% in 2006. Predict when 4% of the players will be African American. All right. So this question is going to have us do a lot of work. The first thing I'm going to need to do is write an equation. And I start with these two pairs of information. So I'm going to write two ordered pairs. Okay. The percentage of players that are African American is going to depend on the year. So my ordered pairs should end up with T for year, T for time, comma, we'll just use P for percentage. Okay. I need to pick a starting year. So we'll let T start in something that references the first year is a good idea. So you can choose 1990 if you like, or 1997. I'll just go ahead with 1997 because it will, as you'll see in a moment, make it easier if I choose the first year. But you do need to write your starting year down so you can refer to it later. Starting in 1997. Okay, so it's going to make my first ordered pair 0, comma, because 0 years to 1997 is 1997, comma, 17. Okay, so the units on this are going to be percent. I'm not going to convert it into decimal. I'm just going to leave it at 17% in the units, which is okay as long as I'm consistent and do that every time. The next ordered pair, I need to figure out what 2006 minus 1997 is to figure out how many years it has been. So 2007 minus 1996 has been 11 years, which would have been nice if I was in 2007, but I'm in 2006. So 2006 minus 1997. I transposed those for some reason. Little bit dyslexic there, but there we go. 2006 minus 1997 is 9. There we go. That's 9 comma 8.4. All right, let's make sure I got those numbers looking right. Okay, so I have the two ordered pairs, and we know, like we said at the very top of this page, that if I'm going to write a model, it's a linear model, I need to find the slope and the y-intercept. With two ordered pairs, I can find the slope first because I know a formula to find slope. So let's calculate our slope. M is going to be y2, which is 8.4, minus y1, which is 17, over x2, which is 9, minus x1, which is 0. Okay. So I need to do 8.4 minus 17. Gives me negative 8.6 over 9 minus 0 is 9. so divided by 9, gives us negative 0.9556. I'm going to keep 4 decimal places, and I am going to round that last 5 up because of the 5 after it. Okay, so just some thoughts. This is negative, which means that it should be decreasing. You can see that it was 17% in 1997. It decreased to 8.4 in 2006, so I was expecting it to be negative because of the decrease there. Okay, and the next thing is I need to find the y-intercept. Remember that when we have an ordered pair that has a 0 in the x-coordinate, we get b, the y-intercept, from the y-coordinate. So we have chosen correctly, or chosen wisely, by choosing the starting year to be 1997 because that gives us the b value for the line. Okay, so the equation for the line would be y equals negative 0.9556x plus 17. Now I don't want just an equation. Let's go ahead and write this as a function. So if I turn this into a function, we're going to use the variables p and t because they describe the variables in the situation, time and percent. Okay, so we're going to use p of t, dependent variable of independent variable, equals, then we'll use our negative 9.556t plus 17. Okay, that's written as a function. Now, I've written the equation. I finally get to the prediction step. Predict when 4% of the players will be African American. I'm going to take that 4 now and I'm going to plug it in for P and solve for T, the year. Okay, so we're going to put 4 equals negative 0.9556 T plus 17, and we'll subtract 17 from both sides. Okay, 4 minus 17, that will give us negative 13, equals negative 0.9556t. I need to divide that negative 9.556 from both sides. Calculator, so got negative 13 divided by negative 0.9556 gives us 13.604. Equals t. Okay, so that 13 is referenced from my starting year, which was 1997. I had that written down to remind me, starting in 1997. So I'm going to add 1997 and figure out what year that would be. So if I type my calculator and just type in add 1997, 2010.6. That 0.6 isn't part of our answer. It's just in the year 2010. It's halfway through 2010, but it's still in that year 2010. We haven't flipped over into the next year yet. Okay, so we'll answer that way. In 2010, for percentage of Major League Baseball players were African American. That is our prediction based on our model. Okay. Let's look at the next one. Example 3. The FBI gathers and publishes data about burglary rates in the U.S., which is the number of burglaries for every 100,000 residents for each year. According to their statistics, the crime rate for burglaries was 1,168 in 1992 and 702 in 2011. Once again, 2 groups or 2 sets of ordered pairs, so I need to write a model. I also want to point out that in part A, they tell me to use T years since 1990 for this model. If you're told a starting year, you have to use that starting year because it will change the numbers that you find for B particularly while you're writing the model. So we want to use the year that was specified. If you're not specified a model, then you would probably want to choose the first year. Okay, so my ordered pairs should be T for year, comma B it looks like for burglary. If you ever wondered why we're using T for year instead of Y, for example, it's because it would look funny to us to have Y in the X position. You would like to see X, Y over here. So we don't like to put Y as an independent variable just because it's usually the dependent. So we use T instead. Okay. Anyway, I digress. So the next step would be to convert these numbers into ordered pairs based on 1990. So 1992 is going to be 2 for the year, 1168. And the next one is going to be 2011 would be 21 years since 1990, comma the 702. Okay, so we're going to find the slope by subtracting y2, 702 minus 1168 over 21 minus 2 equals 702 minus 1168. On the top gives us negative 466. On the bottom, 21 minus 2 is 19. So if I divide by 19, I get negative 24.5263. Usually I keep 4 decimal places. However, this model says it's okay to give 2 decimal places. So I'm going to go ahead and round down to 2 places. If it's not specified again, 4 is a good number of places to keep. Down to 2 places, it's going to be negative 24.53. Okay. Now, I do want to keep 2 decimal places, but that means that I want to have 2 decimal place accuracy in my final answer. So I'm actually going to use all 4 while I'm trying to find the B of the model. Notice that I don't have a 0 for either of my x coordinates, which means I don't know the B value. Instead, I need to solve for it. So we're going to start with just writing an equation. Y equals negative 24.5263 x plus B. And then we're going to fill in the x and y values with x and y values from one of the ordered pairs. It doesn't matter which, so let's just go with the first one. Okay, so that's going to look like, the first y value is 1168. Just did it again, I switch my numbers sometimes. 1168, okay, equals negative 24.5263 times 2 plus B, and we're going to solve for that B to find the y-intercept for this model. So the first thing I need to do is take, let's use the value as it's already there, times 2. Okay, so I've got 1168 equals negative 49.0526 plus B, and then I have to add 49.0526 to both sides. Okay. So 1168 plus 49.0526. There we go. Got 1,217.0526 equals B. Okay, so let me just underline or circle these values real quick. These are the values that I'm going to use to write my equation. Okay, so my equation is, it would be y equals negative 24.53 x plus B. We'll round it to 2 places. That would be 1200 or 1217.05 if I round to 2 places now. And then switching into the letters in terms of the model, instead of the equation, find the function. So I'm going to use B of t equals negative 24.53 t plus 1,217.05. Now, in case you're wondering, you don't have to write the equation with x and y first. You can go right to the function. I'm just trying to make sure we're extra clear where this all comes from. Okay, it's a linear model, so it comes from y equals mx plus b, but I am just switching the letters to make them a function in terms of the variables in this problem. Okay. Next part, what would the model predict as the burglary rate for 2015? Okay, so 2015, I need to figure out what this would be in reference to T. So I first want to take 2015 minus my starting year, which was 1990. So 2015 minus 1990 is 25. So that means that 25 is a T value. So I'm looking at a T value of 25, or evaluating B at T equals 25. So B of 25, since I know the model, will be negative 24.53 times T is 25 plus 1,217.05. So I just need to simplify that. Negative 24.53 times 25 plus 1,217.05. Okay, so it gives me 603.8. All right, and we just want to write this as a sentence for our conclusion. So our conclusion is that in 2015, the burglary rate was 603.8. Last, we have part C. When would the model predict the burglary rate was 800 per 100,000 residents? Okay, remember that the 100,000 residents has always been a condition of this problem. This is not 603 burglaries in the country, it's 603 burglaries per 100,000. Okay, so I'm just going to plug 800 in for the burglary rate, which means plugging 800 in over here. So that's going to give me 800 equals negative 24.53 T plus 1,217.05, and we're going to solve for T. So if I want to solve for T, first I want to subtract off the 1,217.05 from both sides. So I need to figure out what 800 minus 1,217.05 gives us. It gives us negative 417.05 equals negative 24.53 T. So now I want to divide both sides by negative 24.53 on my way to solve for T. Okay, divide by negative 24.53. I get 17.0016. So it gives me 17.002 for T. And again, I am referencing my starting year, which means I need to, this is a T value, a year value, so I have to look back at my starting year. My starting year was 1990. So I have to add 1990. And that gives us 2007. Be curious, I just took 17, I just added the 1990 to get the 2007 0.006, but of course I round that to 2007. So in conclusion, in 2007, the burglary rate was 800. That's our prediction. That's also the end of part A.